So today we're going to be taking a little step back and we're going to be talking about radicals. Now, a radical is any expression that has a square root or a cube root. A cube root would have this, and so on, right? You could have a fourth root, a fifth root, sixth root. It starts to get crazy, but what we'll mainly be dealing with is square roots and cube roots. This symbol that I just made right here is considered the radical symbol. We call it the radicand. And you would know like the first 20 or so perfect squares, right? A perfect square is any number multiplied times itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, then we got 81, 100, 121, 144, and we can go on and on for ever and ever and ever, like 169, 196. I highly recommend when you first start doing square roots, maybe find yourself a little list on the internet of perfect squares so that you kind of have something to look at when you're trying to break them down. What we're going to be talking about today isn't knowing necessarily what the perfect squares are, but how to simplify radicals, right? Because then we can use them to solve quadratics in some instances. So there's a couple cases. Now, case one being if I have a perfect square, right? When I have perfect squares, all I have to do to solve is to take the square root of the number. Right? Now, when we're dealing with square roots, there's something we should understand is where integers are concerned. Say I have a perfect square, the square root of 4. Right? I could just take the square root of that number. 4 is 2 times 2, so its square root is 2. But there's something we need to remember because we're in higher math now. We're talking about algebra 2. And we need to understand that it isn't just positive 2. It's also negative 2. Because if I break this down, you can see that, yes, 2 times 2 equals 4. But negative 2 times negative 2 also equals 4. So that positive and negative are both true statements, right? So when we remove that square, when we take that square root, we got to understand that we're getting two solutions. Case 2 would be non-perfect squares, right? If case 1 is perfect squares, case 2 would be non-perfect squares. When we're solving these, what we want to do is break the radical down using the largest perfect square that's in there. Will they always be breakdownable? No. The largest perfect square. Take the square root of the perfect square. I know this is long-winded, but I will show it to you too. I won't just explain it to you. Take the square root of the perfect square. And leave the leftovers. Leave whatever is left over. Under the radical. So what does that look like? Say I have the square root of 112. Right? I'm going to break that down. I know that 16 times 17, I'm sorry, 17, my butt. 16 times 7, getting out of here. I know that 16 times 7 equals 112. And 16 is a perfect square, right? So what I could do is I could write this as plus or minus 4, because 4 times 4 is 16, times the square root of 7. 7 doesn't break down as a prime number, so I can't pull anything out of it. So that's going to be my leftover under the radical. In both cases, if there's a coefficient outside the radical, this is my little star. If there is a coefficient that means a number on the outside of the radical. If there's a coefficient outside the radical, you multiply it times any number you take out. So let's just do some examples, because that's usually the best way to learn it. So example 1, say I have the square root of 49. Now we know that 7 times 7 equals 49. So in this circumstance, we would just have plus or minus 7. Same with, say, if I had the square root of 225. I could look at that and I could go, okay, well, I know that that is 15 times 15, right? That's the square root of 15 times 15. In which case I can just go, this is going to be plus or minus 15. And is it always going to be that easy? Heck no, it's not, right? What if I have 2 times the square root of 144? Well, we know that 144 is still a perfect square, right? So we can still pull it out the same way. But we've got to remember that we have this 2 here. So it's going to be 2 times plus or minus 12, right? 144 is 12 times 12. So that means I'm going to have either positive or negative 24, right? We've got to remember to multiply this 2 times it. When we're dealing with fractions, if I have the square root of 4 over 9, that's the same as saying the square root of 4 over the square root of 9, right? And we know that the square root of 4 is 2, and the square root of 9 is 3. So we would just have plus or minus 2/3. In the same respect, if I have the square root of 1 over 81, that's like saying the square root of 1 over the square root of 81, which is going to give me 1 over 9, plus or minus. And that's all well and good, right, when we're dealing with these perfect squares. What if I have, let's change it up a little bit. Change it up by changing the color. The square root of 245. I need to break that down. I need to look at what its factors are. So I'm going to look at the factors of 245. And right away, I can look at this and know that it's divisible by 5 because it ends in 5. So I'm going to look at it in those terms. I'm going to go 5 times what equals 245. And in this case, that answer is 49. 5 times 49. So when I rewrite this, I can look at it as the square root of 5 times 49. And we know that 49 is a perfect square, which means that I can pull at least that part out. Now, 49 is 7 times 7, so what we're going to pull out is 7. And we have to leave in the part that we can't break down, which is 5. Let's look at that again with, let's say 5 times the square root of 72. Now, what I know about 72 is that it is divisible by 2, right? It is actually 2 times 36, right? And 36, we know, is a perfect square. It equals 6 times 6. So let's rewrite that. Let's go 2 times 36. So when I take this out, I'm going to have 5 times, well, 6, positive or negative 6, right? But still 6 nonetheless. We're going to call it plus or minus 6, right? I'm just going to put a little plus or minus up here so we know to make it plus or minus when we get our final solution, times the square root of 2, which is going to give me 5 times 6 is 30. So I'm going to have plus or minus 30 times the square root of 2. So remember, anything that we can't break down has to stay under the radical, the radicand. What if I have 9 times the square root of 45? Well, 45 is another one of those numbers. It is not a perfect square, but it is divisible by 5 because 5 times 9 equals 45. And 9 is a perfect square. So right now I have 9 times 5 times 9. And I can pull a 3 out, right? The square root of 3 is the square root of 9. So I would have plus or minus 3 times 9, and we would have to leave the 5. And we would go, okay, well, that is plus or minus 27. 3 times 9 is 27 times the square root of 5. So I think that's a lot of good examples of how to simplify a radicand. And the reason that I want to talk to you about that is that we can use radicals or solving square roots or breaking down square roots to solve quadratics. So that's what we're going to look at now. We are going to solve quadratics using square roots. The way we're going to do that is we're going to use some steps. Step 1, isolate your x squared. Step 2, take the square root of both sides. Ooh, both, not both. 3, simplify the radical. And don't forget plus or minus to indicate both answers. One little piece of information is this doesn't work with all quadratics. We have been looking at quadratics in the form of ax squared plus bx plus c. We can only solve quadratics by square roots if they don't have a bx term, right? Only works with ax squared plus c. It cannot have an x term. The only x term that it can have has to be the x squared. So let's look at some examples of this. If I have x squared minus 64 equals 0, the first thing that it says to do is to isolate x squared. So that means get x squared all by itself on this side of the equal sign. I'm going to do that by adding 64 to both sides, which is going to leave me with x squared equals 64. The next step is to take the square root of both sides. That means I'm going to take the square root of this and the square root of this. Now the square root of x squared is x, the square root of x times x, which means x can come out, right? The square root of x squared is just x. The square root of 64 is going to be plus or minus 8. And those are our two solutions, right? 8 and negative 8 are our actual solutions to this quadratic. Let's look at 7x squared plus 8 equals, we'll say 15. First step, still, right? We're going to isolate the x. We're going to get it by itself. So the first thing I'm going to do is I'm going to subtract 8 from both sides, and I get 7x squared equals, well, 15 minus 8 is just 7. So it's going to equal 7. But technically, my x squared still isn't isolated, right? Because it's got that 7 multiplied to it. So I'm going to go ahead and divide both sides by 7. Now I'm going to get x squared equals 1. 7 over 7 is just 1. Now we've isolated the x squared, right, which was what we were asked to do first. So now we just have to take the square root of both sides. In this case, that's a pretty simple task, right? Because all we have to do is take the square root of this and the square root of this, and we're going to get the square root of x squared is always just x, and the square root of 1 is plus or minus 1. So we're going to look at another example. We're going to try and get a little bit more complex in here for you so that you can see as many possible items as I can give you, but they all will work the same. I don't want green anymore, I want blue. It just wants to give me green, so let's make the green a little bit fatter at least. Example. What if I have 2x squared minus 9 equals 55? We're going to do our first step. We're going to isolate the x. We're going to add 9 to both sides and get 2x squared equals 64. Then we are going to divide both sides by 2, right? That would be our next step. We've got to divide by 2 to get that x all by itself. So we're going to have x squared equals 32. 32 is not a perfect square, right? So when we go to take the square root of both sides, I am going to have to look at what my factors of 32 are, right? Well, it's 8 times 4, it's 16 times 2. I can look at it like that, right? 16 times 2, and 16 is a perfect square, right? It's the same as saying 16 times 2, and 16 is 4 times 4. So I'm going to be able to pull out a plus or minus 4, but I have to leave the 2 underneath, right? So we have 2 solutions. Notice every single one of these is giving me 2 solutions. It's giving me 4 radical 2, and it's giving me negative 4 radical 2. That's what plus and minus mean. And if we took factors, it would work out the same way. Let's do one more example. They're not going to get any more complicated than this on your homework. So I'm going to do one more. I'm going to say, let's look at 5x squared plus 10 equals 310. Now, these are big numbers. They look like they're huge to deal with, but we're still just going to follow the same steps. We're going to isolate this x squared. We're going to start by subtracting 10 from both sides, and we're going to get 5x squared equals 300. Then we're going to do our next step. We're going to divide by 5 because we're trying to get that x all by itself. So I'm going to get x squared equals 60. So we've isolated the x squared, and now all we have to do is take the square roots of both sides. This is going to give me x, but 60 is not a perfect square. Let's look at what it is. The only thing I can think of, I could go, well, it's 10 times 6, but that doesn't help. It's 2 times 30, but that doesn't help. It's also 4 times 15, and I know 4 is a perfect square, right? So I could rewrite this as 4 times 15. Now, 4 is my perfect square. It is plus or minus 2. But 15 is only 3 times 5. It does not break down, so we are going to leave that underneath, and this would be our solution. You have an interesting homework today. It's going to be a worksheet. You'll have to do the even numbered problems on the worksheet that I post in PowerSchool. So make sure you ask if you have any questions. This should be review. This is Algebra 1 stuff, but it's been a while since you guys have done Algebra 1. So make sure and ask the questions if you have them. And I'll see you guys in class.